Okay, I guess I am. So I think we can get started. It's almost time. So let me begin with the screen share. So in the last class, if you'll remember, we had concluded with our discussion on the second order differential equations, right? We had discussed one question as well. So anyone having any doubts from the previous class content? Anyone? Okay, perfect. If there are no questions from the class, then let us continue today with a complete revision of the entire discussion on differential equations. Okay, so we'll be taking different kind of questions and discussing the solutions, and that will be based on all the portions of equations that we have discussed from the very first session. So let us take the first question for today. This is the first question. So it's based on what kind of solution will this differential equation have? Whether it will be a unique solution, that means one possible answer, infinite solutions, multiple possible answers, non-trivial solutions, it implies a non-zero answer, and none is basically the other last one. Okay. So how should we start with this? Can anyone take a guess? So first of all, we need to start solving this differential equation, right? So the question over here is mod of dy dx will be equals to mod of y, right? That is what is given to us. So this can be written as mod or dy dx is equals to plus minus y, right? You all agree with it? So I hope you might have seen this, that let's say if you have like a mod a equals to mod b, then this basically means a can be written as plus minus b. Okay, so I'm using a similar result over here as well. So the moment I write this, now I can variable separate it out. So dy by y is equals to plus minus dx, and you can integrate as well in this way. So that means log of mod y is equals to plus minus x plus c, correct? So this is your general solution, and it is given y of 0 is equals to 1. That is when x is equals to 0, then y is 1. So if you put it over there, what will you get? Log of 1 is equals to plus minus 0 plus c. That means c is 0. Correct? That means your final solution is log of mod y is equals to plus minus x, which implies y is equals to e raised to the power plus minus x. That is, y is equals to e to the power x or e to the power minus x. Okay. So this is your solution to the differential equation. So now can anyone tell me which option will match from these four?
Infinite solution.
Infinite solution. Okay, anyone else? No. Infinite solution is basically like there are large number of solutions, right? Infinite is basically meaning that uncountable number of solutions are there. That is infinite.
Non-trivial solution.
Exactly. Okay, because unique solution means one answer, which is not the case. Infinite solution will mean uncountable number of answers, which is not the case. You are only having two possible answers. So the only option that will match with this situation is non-trivial solution, because you are getting a non-zero values of y as your answer. Okay, is it making sense to everyone? Any questions? Okay, perfect. So let's move on to the next one. For the differential equation, dy by dx is equals to y into y minus 1 into y minus 2. Which of the following is correct? Option A, if y of 0 is equals to 0.5, y is increasing. Option B, if y of 0 is equals to 1.2, then y is increasing. Option C, if y of 0 is equals to 2.5, then y is unbounded. And option D, if y of 0 is negative, then y is bounded below. Option is correct. Can anyone tell me if you understand the meaning of what do I mean that y is unbounded or y is bounded below? What might these two terms mean? Can anyone tell me?
Unbounded means it can tend to both minus infinity or plus infinity, and bounded below means the bound is only below and it can tend to plus infinity as well.
Okay. So the idea is just for others also, I'm just writing it down in short. When I'm saying that y is unbounded, so it clearly means that like the values of y can take can be anywhere between minus infinity to plus infinity. Okay. That is what is unbounded. Okay, so you can think of it like as x tends to infinity, y tends to infinity, or minus infinity, things like that. Okay, so if you go on increasing the values of x, then the values of y can continuously go on increasing or continuously go on decreasing, depending upon whether the function is increasing or decreasing. All right, and when I'm saying that y is bounded below, that means the value of y will have a lower bound at some point a for all x. Okay, where a is a finite real number. Got it? So for any possible value of x, the value of y will not go below a particular bound or a lower limit. So that is the criteria for being only bounded below. And unbounded means for any possible value of y, hello everyone, am I audible?
Yes, sir.
Yeah, sorry, there was a small network issue. Let me just reshare the screen. Yes, so we were discussing this question, right? So is this part clear to all of you? What does unbounded and bounded below mean? This is making sense? So now if you look at the options that is given in the question, you need not necessarily explicitly solve the entire differential equation to get to the answer, right? Because it is only telling you to have a certain idea of whether y is increasing or whether it is bounded below or bounded above, right? So let's say, for example, that if you have a y as a function of x, right? So what will be the solution of this differential equation? It will be something like whatever the answer will be, some y as a function of x, right? If you look at option A and option B, it is basically talking about whether the function will be increasing or decreasing given these particular values, right? Agreed? So that means if you remember, like, what is the criteria for increasing function? Dy dx must be positive, right? Agreed? So that means basically we need to understand that given this differential equation, for what values of y and x will this dy dx will be positive, right? Correct? Is it making sense to all of you what I'm saying? So over here, the options are not explicitly that you need to know the entire solution. You just need to know the sign of dy dx typically, right? So that is why we need not solve this entire differential equation to get to the answer first and then do the options, right? We can do that without looking at, like without solving that explicitly as well. Now, how can we do that? So let's say that you are given this question, right? So over here, your dy by dx is y into y minus 1 into y minus 2. If I ask you that for what values of y will dy by dx be equals to 0, can anyone tell me? For what values of y will it be 0?
Y equals to 0, 1, 2.
Y equals to 0, 1, 2. Right? So at these three values of y, and if I say that dy dx is positive, then what will be the values of y? Can anyone tell me? For what values of y will dy dx be positive?
Any values other than 0, 1, 2. Any positive integer or
No,
fraction
no,
also.
no, no.
0 to 1 and 2 to infinity.
Correct. And how are you getting that?
Normal line rule.
Yes, correct. So let me explain this to all of you in case if you are new to this concept. Okay. Let's say that, let me take a simple example over here. Fx equals to x minus 1 into x minus 2 into x minus 3. Okay. If I ask you that for what values of x, fx will be positive. Okay. So what do? You can simply draw a number line like this. Okay, for all values of x. And you can then plot the values of x for which fx is equals to 0, which is 1, 2, and 3. Okay. So these three values at which fx is equals to 0 splits the entire real number line into 4 parts. Correct? Agreed? Everyone? So let's say if you are talking about values of x greater than 3, x minus 1 will be positive, x minus 2 will be positive, x minus 3 will be positive. So the result is positive, right? So fx will be positive for all values of x greater than 3. If we are talking about values of x between 2 and 3, x minus 1 will be positive, x minus 2 will be positive, but x minus 3 will be negative, right? So the result is negative, right? Okay. If I'm talking about values of x between 1 and 2, then x minus 1 positive, x minus 2 negative, and x minus 3 negative. So the result is positive. Okay. And for values of x that are less than 1, all the three products will be negative. So the result is negative. Correct? Can you see one interesting observation in this diagram? That the sign of fx is alternating in every interval, right? Agreed? So the idea of this number line rule is that you start from the extreme right interval, put a plus over there, and continue to alternate the sign in every other interval. Okay. So from this diagram, what can you see? That fx will be positive when x belongs from open interval 1 to 2 and 3 and beyond, which is 3 to infinity. And fx will be negative for all values of x less than 1, that is minus infinity to 1, union 2 to infinity, union 2 to 3. Okay, got it? Is it making sense? So here also I will construct a similar kind of a number line kind of a diagram for y. So y, if dy dx is 0 at 3 points, right? 0, 1 and 2. So I put a plus over here, minus, plus, minus. So dy dx will be positive. That implies y belongs from 0 to 1, union 2 to infinity. And dy dx will be negative. That would give us y belonging from minus infinity to 0, union 1 to 2. Okay. Is this making sense to all of you? Any questions, anyone? Is this fine? Okay. So now let's go back to the options. What does it tell us? So over here, let me maybe draw it better on a graph that will be easier to understand. So if you look at all the four options, it is talking about y of 0, right? That means we are talking about x is equals to 0. We are talking about points on the y-axis. dy dx is 0 at 3 points, right? 0, 1 and 2, right? These are the 3 points at which dy dx is 0. That means the curve will be parallel to the x-axis at these 3 y values. Correct? Okay. Now, if you look at the options, if y of 0 is 0.5, then y is increasing. 0.5 kahan hoga? Between 0 and 1. Correct? And between 0 and 1, what is dy dx? dy dx is positive. So the curve will be something like this over here at this point. Right? So option A is correct. Is it making sense to all of you? How we got this?
Yes, sir.
Yeah. So similarly, can anyone tell me whether option B is correct or not? So if y of 0 is 1.2, so 1.2 will be over here, right? Somewhere in between 1 and 2. So if y of 0 is 1.2, is y increasing?
No.
No, right? Because 1.2 means we are talking about y belonging from 1 to 2, or wahan pe dy dx is negative, right? Correct. So the curve will look something like this. Whatever it is, it will look negatively sloped, right? So option B is out. What about option C? if it is 2.5?
Why are we plotting these slopes against the y-axis? It shouldn't be against the x-axis.
I'm not plotting the slope. I'm plotting the possible shape of the curve, right? Correct. You are
Uh,
talking about the slope of the function at the point x equals to 0, right? Y of 0 means what? You are putting x equals to 0. So we are talking
hmm.
about points on the y-axis. So we are talking about the shape of the function on the y-axis.
Oh, okay. Okay.
Yes. Right. So what about option C? Anyone? So for y equals to 2.5, what is the expected sign of dy dx? So 2.5 means more than 2. So for 2 to infinity, dy dx is positive, right? So that means if if y of 0 is 2.5, then the slope of the curve at this point will be positively sloped. Correct? And for all other higher values of y, dy dx is positive, right? dy dx is positive for all values of y from 2 to infinity. मतलब अब y का वैल्यू जितना बढ़ाते जाओगे, dy dx will continue to remain positive. So the curve will be something like this. Concave or convex, but it will go on increasing, right? Correct? Agreed? So that means if y of 0 is 2.5, I can at least say that y will be unbounded above. That much we can say, right? But that does not mean that it's fully unbounded, right? It might not be unbounded below. So we don't have enough information from this to say that y will be unbounded below. Correct? Okay. Is it making sense to all of you?
So can you explain once again?
So y of 0 is 2.5, right? So 2.5 means what? It is between 2 to infinity, correct? So between 2 to infinity, what is the sign of dy by dx? It is positive, correct? That means at this point, when x is 0 and y is 2.5, what is the slope of the curve? Positive, correct? So the curve will be increasing, right? And the condition that you got over here is that dy by dx will be positive for all values of phi between 2 to infinity. Correct. That means if you go on increasing the value of y, correct, dy by dx will continue to increase. है ना? So how will the curve look like? dy by dx positive मतलब x जितना बढ़ा रहे y भी उतना बढ़ेगा and the curve is continuing to increase for all values of phi from 2 to infinity. So it is unbounded above, right? If y of 0 is 2.5, then we can say that y is unbounded above. Okay, is it making sense to all of you? Any questions? Anyone? Any other doubts on this? Is it fine with all of you?
Yes, sir.
Yeah. So I can say with assurance that if y of 0 is 2.5, then it will be unbounded above. But can I say anything that it will be unbounded below? No, right? We don't have enough information in this option to say that. Okay, got it? So this option C, it's partly correct, but not fully correct, right? So that is why we will be rejecting this option. And what about option D? If y of 0 is negative, then y is bounded below. So y of 0 negative matlab some value of y which is over here, let's say. This is a negative value, right? So for any negative value from minus infinity to 0, what is dy by dx? It is negative, right? So it is decreasing, right? It will continue to decrease. So the curve will be something like this, right? And dy by dx is negative for all values of y from minus infinity to 0. Okay? That means आप y को जितना negative लेके जाओगे, dy by dx will continue to be negative or it will continue to be decreasing. So there will be no bound below, right? The value of y will continue to fall if y falls below. So that means option D is also incorrect. Okay, got it, everyone? Is it fine with all of you? Any questions, any doubts, anyone on this?
No, sir.
Okay, all right. So if this is fine with all of you, then let's move on to the next question. So let me discuss one of this format. Let's say that the solution of the differential equation x dy minus y dx is equals to is four options. Y is equals to x sine of log x. Option B, y is equals to x squared sine of log x. Option C, and option D, none. Okay, so this question is rather straightforward as compared to the last two. It is simply asking us to solve the differential equation and see which option is correct. So first of all, we need to understand that how we are going to solve this differential equation, right? So can anyone take a guess as to how we should start? So that is x dy minus y dx is equals to under root of x square minus y square dx. How should we
স্যার
start?
এটা তো হোমোজিনিয়াস ইকুয়েশনের মতো আরএইচএস এলএইচএস এ এক্স বা ওয়াই দিয়ে ভাগ করে দিয়ে সাবস্টিটিউট করে দিলে হয়ে যাবে ওয়াই বাই এক্স ইকুয়ালস টু পি বা টি যা হোক
ঠিক আছে, so we need to bring it to homogeneous form, right? So let's say x dy is equals to under root x square minus y square plus y times dx. So dy by dx can be written as under root of x square minus y square plus pi divided by x, and this can be written as under root of 1 minus y by x whole square plus y by x, right? And then I will substitute it. So let y by x be equals to v. So this is a homogeneous differential equation, right? So that means your y will be equals to vx. If I differentiate it, dy by dx is equals to v plus x into dv by dx. If I replace it in place of dy dx, v plus x into dv by dx, and this will be under root 1 minus v square plus v. So v is out. So x into dv dx is equals to under root of 1 minus v square. So dv by under root 1 minus v square is equals to dx by x, and that integration. So what will be this integration? Can anyone tell me?
LHS টা হবে sin inverse u আর RHS টা হবে ln x plus c.
So sine inverse of v is equals to ln x plus c. Okay. And what is the c coming out? We need to get that from the condition given to us. So y of 1 is equals to 0, right? That means if I put x equals to 1, my y will be 0. So sine inverse of v is y upon x, right? Is equals to log of mod x plus c. So if I replace this value, so sine inverse of 0 is equals to log of 1, which is log of 1 plus c. So what is c?
C will be 0.
C will be 0. So that means the solution is sine inverse of y by x is equals to log x. So which option is matching?
Sir, option A.
Option A. Because if we rewrite it as y by x equals to sine of log x, and then y will become x into sine of log x, right? This is option X. Okay. Is it fine with all of you? Any questions? Okay, perfect. So let's move on to the next question. If the integral curve of the differential equation passes through then alpha equals to how much? Option A, 2 minus 1 by e. Option B, 1 minus 1 by e. Option C, just 1 by e. Option D, 1 plus e. Okay, this is the question. Now, before proceeding with this, can anyone tell me what might this term mean? Integral curve. Anyone?
স্যার ইন্টিগ্রাল কার মানে কি ইন্টিগ্রেশন করার পর যে ফাংশনটা পাচ্ছি ওইটার কার?
Exactly. So basically, what they're trying to tell you is that integral curve is basically the solution of the differential equation because you need to integrate, right, to get to the solution. All right. So what they are saying is that the solution of the differential equation passes through the point 0, 0 and alpha comma 1. Then what is alpha? Okay. So don't get confused by this terminology. This might be there in some questions. That is why I'm discussing this. So the integral curve means nothing but the solution of the differential equation. Okay. The y as a function of x that we will get as a solution, that is what they're talking about. All right. So the question I believe now is looking relatively more simpler. So the idea is that you are given a differential equation and you are being asked that the solution of the differential equation, which is y as a function of x, passes through 2 points. Then what is alpha? So what we need to do? We first need to solve the differential equation and get the solution, and then we just need to put the points and get alpha. Okay. Is it understood by all of you? Is it making sense? Any questions on this? Anyone? Okay. So the next part is obviously to identify what type of the differential equation is this, right? So that we can solve it accordingly. So can anyone tell me how should this be solved? So the differential equation is y minus x whole into dy by dx is equals to 1. Anyone? What might this be? So if you write it in this way, just check this out view. Dy by dx is equals to, this will be 1 by y minus x, right? So I can't variable separate it. But if I flip it, dx by dy is equals to
ওটাকে উল্টা দিয়ে ইন্টিগ্রেটিং ফ্যাক্টরের মতো করলে তো
exactly. So dx by dy plus x is equals to y. So this is looking like a linear differential equation. Correct? So if you remember, I'll just write it down for all of you in case if you have forgotten. So the linear differential equation can be written in two formats, right? The first one was dy by dx plus p times y is equals to q, where p is some function of x and q is also some function of x, right? So in this case, you calculated your integrating factor as e raised to the power integration p dx. And the other format which we are getting over here is dx by dy plus p times x is equals to q, where p is some function of y and q is also some function of y. So in that case, you would calculate your integrating factor as e raised to the power integration p dy, right? So in this case, we are basically having the second form of the differential equation, right? So here, your p as a function of y is simply 1 and q as a function of y is y. So your integrating factor will be e raised to the power integration p dy. So e raised to the power integration 1 dy, which is simply e raised to the power y. Okay. And what is the next step of solving a linear differential equation? You will multiply the differential equation with the integrating factor, right? So that is e raised to the power y into dx by dy plus x is equals to y into e to the power y. Right? Correct? Making sense, everyone? And then we need to work this out. All right. So let me put this as a homework for all of you. Now this that we need to just solve this linear differential equation. Okay. So I'll request all of you to please give this solution a try and maybe complete it as well. And then we can come back and discuss the solution to this in the next class. Okay. Got it, everyone? Any questions on this? All right. So if there are no other questions, then I think we can conclude the class here for today. So thank you everyone for joining. See you all in the next class. See you all can disconnect. Thank you.